Okay, this is our video demonstration of the Royce 620 bond pole tester. Right now I have it plugged into a 110 outlet. I have 60 psi of air on the ring input, as well as I have a vacuum pump connected to the vacuum port. These are on the back of the system here. Here's our pump. It's our air line coming in, again 60 to 80 psi, and then this is your vacuum line. 110 volt plug is right here, and then you have your other connections too, as there's two USB ports connected, and your monitor, and as well as a mouse, just to make it a little bit easier to navigate the software that comes up. So the first thing I just want to point out too, there are two load cells that come with the system. The first one that's installed right now that's in place is the wire pull tester. It's 100 gram, rated at 100 gram, and then you will also demonstrate the die shear, which is a 5 kilogram shear tester. There is an Olympus microscope. It has this protection screen here put in place. Basically you just unscrew the nut here, the little screw in the back here, and that'll come off. Let's just take that off for now. Also want to point out too, there's a focal point reducer of 0.75 that needs to be in place. Now this is manually adjusted by moving this back and forth, just by pulling on it.
If the locking brackets were on, they tried to turn on.
And you adjust the focus here. Also, I want to point out the stage. Right now I have a hook that's used for calibration that's in place here for the wire pump. And I'll put it back in place in this box. And this will come along with the system. We're also going to send along a calibration kit, which I'll explain later, that is necessary for the let me try to get this in the camera. It'll be in this box here. It's the cal kit for the die shear or wall shear, but in our case it's a die shear, and I'll demonstrate how that's done. Now this stage here, because of the vacuum and the air that's on the back, it's in place. It's not necessary for a wire pull to actually have a vacuum holding down your work holder here, but if you want to move it, you need to press this button here, and then you just slide it around, put it in position. Now it's locked again when it's under vacuum. Okay, again, I'm going to remove the screen just so that we could have a better look at the wire pull being done, or at least the test sample that I'm going to show you. So you do have your keyboard and mouse, your screen on the left side. On the right side, you have your joystick as well as your keypad. I'll go over that later. That gets connected here. Okay, so the first thing I want to do now is we'll go ahead and let's boot up the computer. With this system here, just want to point out too that this during the die shear, this bottom stage down the bottom here, let me The stage here moves. It moves about a ½ inch. I'll demonstrate that when we do the die shear. During wire pull, this does not move. Just the load cell moves up and down in this direction. In die shear, once we replace the other module, I'll demonstrate how it's going to come down to a touchdown, lift up slightly, and then your bottom stage here moves in. Alright, so let's go ahead and one other thing to point out too is there is a port here, USB port, so you can save save information or programs that you want to save for future use. You can put it on here, and it's just another storage point for you. So let's go ahead and we'll start up the. I don't think that was in camera. Here's your USB port. And here is your on-off switch. I just want to point out too, while this is booting up, there is a little note on the top. Where is it? I'll leave this on here, but basically to log into into Windows, you're going to need the password of device 1350, and then once we log into the Royce software, we're going to use administrator and admin as our login. Okay, so we have our screen here. I'm going to use the mouse. Again, the mouse is just for a little bit, make it a little bit easier than using your trackman on the keypad. So we'll go ahead and click on that lab device, and we'll log in with capital D device 1350. Go ahead and hit system 620 BPM. Double click on it. And at this point, we're going to go ahead and log in with administrator. Okay, what I'm pointing out is the light turned on, and we'll go ahead and hit the home button. As you can see, the stage is moving up to its home position, or its park position. Okay, now that we're in the park position, what I'm going to go ahead and do is I'll go ahead and hit the unpark Z on the screen. See the light turns on and the hook is moving down. At this point, you can go ahead and hit your lower limit by selecting that on the screen. Not sure if you can see that. joystick will bring that down. One thing to point out too is if you were to move left and right, as you can see, the hook is turning. So with the wire pull, it's one of the features. You rotate the hook as well as bringing it up and down. So what we want to do is set the lower limit. It doesn't crash, and let's call it this, and go ahead and hit the lower limit. That sets that. And if you want to use a search, set a search, you can go ahead and position the hook where you want it to search to. And set that. Okay, so what I'm going to do now is, let's look at our screen here. I'm going to point out a few things about the software. First of all, if you were to hit the help button here, you can go ahead and access the user guide. Explains how to use the system. Exit out of that. The other thing is we're going to go into service module. And here we can do, say, something, for instance, as we'll know that transducer module, and we'll go into the calibration wizard. You can see it automatically detects what module is in place. You can see SMW100G, which is a 100 gram wire pull. At this point, we'll go ahead and do a linearity check. Start with 100 gram force. Here I'll just put in active 100. Yeah. And hit next. Okay, so what I'm going to do is I'm going to set up one of our weights that we have here. I'm not going to change the calibration because these aren't certified. I just want to see how close it is calibrated. This is one of our 100 gram weights here. Move the hook up out of the way. Place the weight underneath the hook. Okay, once we have the weight position, we'll go ahead and hit start or hit next on the screen. Let's look at the screen. Okay, and at this point we'll go ahead and hit start by pressing either the start from here. Pull it, I believe, 3 or 4 times. That's one. Let's take a closer look here. You see the weight is lifted up off the pad. Okay, so then we get our results. you want to see exactly what it read, go ahead and hit the low force detail. All right, so basically I went through this procedure. I'll do one more. Let's go ahead and do the now you can see that it's in position. I'll bring the hook down slightly. Highlight the 10 GF. You can see that. And here I'll go ahead and put in at the 10. Then I'm just going to go ahead and hit the start button by using the star. Oh, it doesn't like that. Let's go ahead. Wait a minute. Hit next. Next. Let's try it now. We're going to have to start from the screen. So it's similar to the 100 gram. Okay, you can see that this one passed too. So it looks like the water pole module is still in calibration. So it measured 10.013 with a difference of 0.0132. Okay, so that's what I done. I did it all on all terrain. I verified that each weight was correct. The only difference is that I don't have a 20 gram weight, I have a 25, so I just put the 25 there, and I wanted to see what it pulled. So I'm going to go ahead and quit out of here. What I did is I saved it to the flash drive up here, and so what I'll do is just miniaturize this. through our folder, take a look at what I got previously. As a matter of fact, it's saved right here. Here's the results I got. I did this the other day. So for the 100 gram, it measured 100.02. The 50 gram was 50.03. Here again, I have to change it to a 25, so it actually measured 25.018. And then the 10 gram we measured at 10.03. Okay, so what I'm going to do next is I'm going to go ahead and swap out the module. Okay, what you need is a 5/64 Allen wrench or an L wrench, and you go ahead and, well, you know, I think first we're going to go ahead and move this back to the start position. Just get it out of the way. Moving the park, we're going to send along a couple of hooks here. I believe that's a 2 mil hook and that's a 1 mil hook. There's 2 in each. We'll send them along, and they come with the L wrench that's necessary to attach them once we take this off. So what I'll do is I'll go ahead and remove it. And this is the cowl hook. So I'll put this back in its appropriate container. Again, this is a 5/64 Allen. We'll send this along so that you can check the calibration, as well as these 2 hooks. And it's two sets of hooks. Then what you'll do is at this point is go ahead and put on your actual hook that you're going to be using. I'm not sure what size this is. I believe it's a 2. Okay. So at this point, you can put your place your work on a holder. Go ahead and move back to on park. Move this out of the way first. Make sure it doesn't crash. I don't think it will. At this point, you want to go ahead and set your lower limit. You want to bring this down so you just about touch the substrate surface. To go below that, and we'll go ahead and call that our lower limit. Move up slightly, and for instance, we'll just use that as our search height. See, the hook does rotate. Move it up and down. Show you what the screen is doing. So I reset the lower limit and the search height. So what we'll demonstrate next, and I'll go through the same process, is we'll look at the 5K die shear. And again, I did the same type of calibration check, and I'll show you the data I received on that. So First thing to do now is I'm going to go ahead and move back into the park position, and I'll swap out the modules. So the best thing to do here is go ahead and bring down the protector. That'll protect the tool from hitting anything. Loosen the nut that's behind. You can see that from this angle. And then you just slide up the line. Side here. This one's the hole. Using. Put the other one off. You go ahead and slide that. Tighten up the nut. Bolt. And remove the protector out of the way. As you can see, that does have a die shear on it. And the software recognizes that the module has been changed, and it's asking you what test group you would like to use. So we'll select the die shear 5K. And if I were to hit recipe settings, you can see what the settings are in this particular program. Again, all of this is explained in the manual. So we're going to accept that. What I want to do next is I'm going to just show you how the touchdown works, and I'll do and show you how the bottom stage moves. So at this point, I'm going to go ahead and redo the lower limit. And what they would recommend is that you go slightly below the actual surface so that it will be able to touch down, make contact with the surface, and then lift up. Bring it down to about here. I'll go ahead and set that as my lower limit. Move it up slightly above. And then set that as my search height. Just going to do a motion test here, show you the movement. Try to get the screen in play here too. So you're going to watch as I hit this start the test. It's going to come down, touch the surface, lift up slightly, and then this bottom stage is going to move. That's typically the movement that you'll see in the die shear. So I'm going to go ahead and hit start. You can see that the stage is moving. There are numbers on the side here telling you how far it moved. So it moved 5,007 microns, for instance. I don't know if you can see that on the screen. Obviously not. It's very small. I'm pointing at this right here. And the other thing I want to point out to you, you can see that the just moved slightly. So it moved that distance, the 5,000 microns. This one I'm going to go ahead and hit abort test. And just one thing to point out, I came across this, is there is a limit sensor on that travel. So what has happened here is when I try to do another test, it's in error. So you can see we're getting an alarm. Why? The only way to get out of this is you go ahead and click the error, the alarm why. You hit status error. I'll show you that there's an error here. Close that out, hit enable. Status error again, close it out. And then go back to enable again, and then hit home. Now the stage moves back to its home position. That's in case you get that error. That's how you clear that error. Is you have to get this to enable, and once you enable, you go ahead and hit home. It wasn't on the screen there. So you click on the error till you get this box up here, and once it's enabled, you can then press home, and the error will be clear. Right. So let's try to get a better look at what's exactly happening with the shear tool. Typically you'll place this directly behind the die and then push on a die. Size mag we'll get out of this. Move one of these lights. There you go, the light's trying to. What I'm going to do is I'm going to abort the test before it hits the 50,000, and we'll go ahead and demonstrate the touchdown. So the module moves down, touches substrate, lifts up slightly, and then starts moving. Point I'll hit abort. Go back to where it started. So again, I'll hit start. And abort. Okay, so that's the motion test on the die shear module. What we'll do next is I'm going to demonstrate how I did the cal check on it. Okay, so I'm back in the park position, and what I'll do is I'll remove the load cell. Put the protector down, loosen the bolt here, and then slide the module. And take our calibration kit. See the It may be best if I just take this microscope out of the thing. Let's see a good look at that there. Shear tool out. It's a typical die shear tool. That's 50 mils. This is part of the cow pit. It's got a flat on the side, so we're going to put that flat at the top. Put it in the hole where the tool was, and tighten that up with the wrench. And then finally, use the string here. You're going to hang out from here. So I'm just demonstrating what I did. I guess we can do one. Oh, man, here's a 5 kg weight. You know, actually with this one here, I had to, doesn't have a hook on it, I had to put the string through to hold it. Just place here. Now, you know what? If I took this off there. Oh, you can't see that. So what I did is I removed the substrate holder. Put the pad on there. Got the string around the 5 kg. Rope. Okay, we're getting a collision error, and you'll get that because of the orientation of the module. So what you need to do is go ahead into service module, and again we'll do the calibration wizard. It's telling you that you have the 5K module in place, right? And we'll do the 5K. We'll do a linearity check. So it's activated 5K. Telling you to set the you want to set the weight onto the module, and you'll have to bring that down. Alright, that's a little too far. Bring it up a little bit so it just gets taut, and then drop it down. You can see that. Just underneath it. Alright, and we'll go ahead and hit next. And start. And it's similar to the wire pull, except for now you're pulling 5 kg using the die shear tool. Important here is you want to make sure that the tool is lifting. I may not have a position for it correctly, so I'm going to hit a board, back. It only travels a certain distance, and I want to make sure it's going to actually lift it up off of there. Next, and start. There you go, you can see that the weight is lifted. Again, I'm not changing the calibration, I'm just testing it. Alright, so it's telling me it pulled, they measured up 4.988. So let's go back. See if we can get that to pass. I'm going to move it up just slightly more, and I'm going to go ahead and try it again. Although 4.988 is very close. Got to make sure you are lifting it completely off the pad. Alright, well, this time we're getting a 5.014. So that's what I did. I did that with all 4 of the weights. Although I don't think I had a 2 kgf, I had a 2.5. So I did the same test with 2.5, a 1K, and 0.5 kilogram. Here's the 2.5. What I did is I saved the data. So that there would be a wire pull. Put out of this, neutralize that. Linearity check using the 5K shear module. Just to show you what the data is on that. Okay, so here are the actual measurements I was able to read off of this. So the 5 kg gave me a 5.028. The 2 was actually a 2.5, and it gave me a reading of 2.5046. The 1 kilogram gave me a reading of 0.9990. and then I did the 0.5 twice, and as you can see the readings were 0.49335 and 0.493000. So that shows that the load cell is working properly. Again, we're going to send along a few shear tools for you. We've got one that's a 50, I believe that's mils, 50 mils wide. This is a 30 mil wide. There's two of those, plus the one that was in there, which is also a 50. All right, that's our video demonstration of the Royce 620 bond pull tester.